Like many of you, I am always working on improving my skills as a maker, and lately, one of my big goals has been to develop better CAD skills. After all, CAD skills are some of the highest impact, highest return on investment skills that you can invest in as a maker. Unfortunately, I just can't justify spending the time to model things that I don't actually need just for practice. So for this reason, my learning method of choice is generally to actually design and build the things that I actually need for actual projects. So lately, I've been making an effort to solve more and more of my problems using CAD. Sometimes this means designing things in CAD and then using other tools like lasers or power tools to actually build them. But more often than not, this means bringing 3D printing into the mix to design completely custom, one-off solutions to my particular problems. Side note here, since I am a content creator, a lot of these problems invariably involve videography and camera equipment. But don't worry, because I am going somewhere pretty interesting with all of this. That's why in this video, I'm going to take you through 7 different solutions that I've recently designed for some of my own real-world problems. I'll share with you how I, someone who is not trained as an engineer, actually approached the problem. And while I'm not going to bore you with a CAD tutorial for each thing I modeled, I will share some of the cool tricks and tips that I learned and used along the way, both to design and to print these solutions in a way that is software agnostic so that you can try them out on your own projects as well. Plus, I'll even sneak in some project updates for the devoted regular viewers among you, and I'll tell you how one 20-minute CAD job saved me over $100. Ultimately, my goal for this video is to give you some inspiration to tackle some of your own problems using CAD and 3D printing. And in so doing, I want to help you level up your own maker skills beyond just printing readily available models. Though, if you're like me, you'll probably be really entertained by just watching another maker solve problems, even if you can't actually relate to the problems themselves. Oh, and by the way, if you're new here, this channel is all about helping you get more out of the hobby that is 3D printing, whether that is product news or tutorials, project ideas. So if you love 3D printing as much as I do and you want to learn more about it, don't forget to hit that subscribe button. All right, let's get after it. All right, let's start the video off down here on the floor with one of the projects that I am most proud of and which I get the most value out of day to day. So for each of the projects I'm going to share, I want to try and outline the problem and the design challenges first. With this one, the challenge that I was trying to solve was one that you've probably seen a lot of other content creators talk about recently. Tripods are super annoying and they're inconvenient if you're always moving around and trying to film things from different heights and different angles. So I have been acquiring all of the different parts that I would need to make my own kind of one stand studio type tripod thing. I've got all these different quick adjustment light things. I got a mount for my laptop. I got a fluid head over here somewhere for the camera. But to my dismay, once I got everything set up and assembled, I found that the locking and folding mechanism on the legs had too much play in it, which meant that every time I applied any pressure to the camera fluid head arm, it would pivot the camera down a bit and make the footage basically useless. So the challenge was to create a kind of reinforcement which would add rigidity to this whole thing while not taking up too much space here, because the last tripod that I had legs that came out in a curve and I was always tripping over them. Now, as with all the projects and all projects in general, I began by getting the dimensions for the pole, the legs, everything I needed. And then I modeled out the existing stuff in CAD so that I could design around it. Now I went through some different iterations. I test fit a cutaway and all that good stuff. And then I tried printing it in one solid piece, but it failed. So I decided to conquer my fear of multi-part assemblies, and I broke this design up into 4 pieces. First, a core in the middle, and then 3 legs that slide onto it and attach with kind of a key system. Now, this has a number of benefits. First of all, if a print of one of the legs fails, it's not as big of a deal as if the entire thing were to fail. Second, because the legs slide on and off, I don't completely lose the ability to fold this thing, even if it does take removing 6 screws in order to do it. Maybe I would have gone through the steps a little bit differently if I decided to make it an assembly from the beginning, but I actually found it really easy to model it as one piece and then split it up and add all the different mating features that it would need later on. So the lesson there is that while there's probably always a more efficient way to do things, assuming you're using a CAD program like Onshape or Fusion 360, which has a non-destructive build process and the ability to roll back and forth in time, there's really no wrong way to do it. So if it works for you, do it in the way that's easiest for you to understand. Now, design-wise, this really wasn't too difficult, but there was one unique challenge that I do want to point out for your edification. This design mixes 3D printed parts and metal parts, which meet up in various different points throughout the design, including on the smooth pole, the legs, and the metal hardware. So this meant that I needed to be mindful of what size tolerances I was using and modeling at different points in the print. Actually, I had too tight of a tolerance on the main center bore, which meant that I needed to sand it down. So the lesson there is just be mindful not only of the tolerances, but also of how 3D printers tend to make some dimensions like holes smaller during printing. And when in doubt, print a cutaway test piece so that you can check your tolerances. See, I'm already using it to find better, cooler angles and excuse the mess, ongoing project. But up next, I want to share a really cool little challenge that actually saved me a bunch of money. So all around the studio, I use 2 different types of quick release plates for mounting different types of gear. For mounting cameras onto tripods and stands, I have dozens of these really big suckers all over the place. But more recently, I've begun using these clever little ones from Small Ring that are called the HawkLock, and I use them for things like lights or microphones, even mounting cameras from the top. The only thing is, they're not cheap. $22 plus shipping for a complete set is honestly completely fair, but then each little additional plate is $14 plus shipping. Now that's well worth it for suspending a $2,000 camera overhead, but I have over a dozen little LED lights that themselves barely cost $14. And call me cheap, because I am, but I'm not going to spend $140 just on top plates for my lights and microphones. Fortunately, I did realize that I can just order very small 1/4" 20 hex screws from AliExpress for under $1 each, and then model my own plates using a caliper to carefully recreate each feature exactly as it appears. Now, at first, I wasn't sure if these would actually hold up under the pressure that the spring mechanism exerts on this lip, and that presented an interesting challenge. If I were to print these in the most obvious orientation with the large flat surface down on the build plate, I would be orienting the layer lines in exactly the worst possible way, inviting the part to fail. So instead, I did 2 things. First, I chose to print these out of Polymaker's Polymax Tough PC, which has the highest layer adhesion of nearly any material that a consumer can 3D print. Second, I chose to print them standing up on their sides with tree supports. Now, I know it seems crazy to print these on literally the smallest possible surface, especially using a material that is known for warping and bed adhesion issues, but if I want the strongest possible part, this is the way it's gotta be. And I have a secret weapon up my sleeve that I'll share in just a minute as to how I actually got these to stay on the build plate successfully. Well, I am very happy to report that my efforts paid off because I've been using my own homemade versions of these clip plates, and they've been working great. The fitment is pretty much spot on, even if they don't have the exact same satisfying metal-on-metal click as the original, and they've been holding up really nicely for the lighter weight gear like microphones and LEDs. Now don't get me wrong, I'm still going to use the original metal backplates for my camera and for my bigger, bulkier lights, but now I have plenty of these backplates for adding quick release plates to the lighter weight gear all around the studio. All right, I really hate to show you guys even more mess, but there's kind of no other way to show you guys this. So how about one more video studio one before we move on? Now, with all my lights and microphones mounted safely overhead thanks to the HawkLock adapters, I had more cables than ever before that I needed to route. Microphone cables, power cables, the occasional charger cable if I'm using my phone overhead for a time lapse. Now in the past, I have used these kinds of handy Velcro straps to secure cables to the various different holes around the studio, and they're great if you want the cable to be fixed in place. But in my case, I'm always moving these arms around, moving things, adjusting the angles of all these different arms. And what happens is that with the Velcro, I would need to completely loosen up all the different straps every single time that I needed to move things around, which was so annoying that I ended up just letting the cables fall to the ground. And as you can see, I really don't need any more excuses to make a mess. So what I really needed was a series of clips that would securely hold on to the pole while allowing the cable itself to slide back and forth when I adjust the arms. So I hopped into Onshape, I modeled a quick clip with the exact dimensions that I needed, and then to make it easier to actually move these around if I needed to in the future, I sketched out some little grip pieces that you're seeing on the screen, being absolutely careful to ensure that they would not overhang more than 45 degrees from the build plate when printed. I then used the revolve feature to add them to the part on one side, and then I used another revolve feature, this time with a starting offset, to add them to the other side without having them show up in the middle of the part. I then printed out a whole gang of these things in PETG because it flexes nicely, but it also suffers from less deformation over something like PLA. And hey, they actually worked. In fact, they worked so well that I actually decided to model up 2 more versions of them for the standing Varipoles I have here in my studio, which have a different diameter on the top and on the bottom. I also made use of the inbuilt text feature in Orca Slicer to add top and bottom, because I do find it much easier to add text to a curved surface in the slicer than in Onshape. Now, admittedly, these ones are a little bit less of a success, partly because the Varipoles are so incredibly smooth that things slide around a lot, and also partly because I do think I should have modeled these to be proportionally thicker when I scaled up the design. They work, but I think I might thicken the walls in the future so that they'll grip on a little bit more firmly, at least on the Varipoles. Now, at this point in the video, you might be wondering, Jonathan, that's the second time we've seen you printing things with minimal contact area on the build plate, and your parts don't detach or warp, even when they're printed in notoriously difficult polycarbonate. What gives? Well, it's at this point that I do need to reveal my secret weapon. A secret weapon that I use for basically every single one of the 3D prints in this video, and a secret who, incidentally, is also the sponsor of this video. Thought 3D, the makers of Magigoo. Magigoo is a line of meticulously crafted 3D printing bed adhesion solutions designed to make adhesion issues a thing of the past. They offer a version for PLA, PETG, and ABS, a version for high-temp materials, a version for PC and ASA, and even many more specialized versions for things like Ultim. And let me tell you, this stuff works. Simply apply it to your build surface once every 7 to 10 prints, and print failure due to bed adhesion literally becomes a thing of the past. What's more, I really love how Magigoo's applicator applies an incredibly thin, almost imperceptible layer to the build plate so that there's no scarring or defects transferred to the print itself. Seriously, guys, you know that I would only ever advertise products that I personally use and love, but I'm not exaggerating when I say that this specific product is hands down one of my favorite 3D printing products that I've ever discovered. And to help make it more affordable for all of you guys to experience it yourselves and actually see what I'm talking about here, we've partnered with Magigoo to give you guys an exclusive 15% off discount for TNL subscribers. So simply visit the link in the description or go to jle.vi/Magigoo and use coupon code TNL at checkout. All right, let's get back to the video. Up next, let's switch gears, no pun intended, and talk about my 3D print recycling / ongoing nightmare of a project. As you might recall, if you saw the latest installment in this series, I've been really struggling with clogs on my recycled filament, and no amount of washing or tossing it around with a magnet seems to be enough. So over time, I've come to realize that a big part of my problem comes not from contamination in the old 3D prints, but actually from small pieces of wood chips and welding flux that are falling off of the design when the motor exerts incredible forces on the shredder. To solve this, I decided to just model up a customized funnel, which would funnel the shredded plastic directly from the sieve into a hole in the plastic bin while keeping all of these small little wood chips and soldering welding flux outside on the lid itself. So to do this, I jumped into Onshape where I already had the CAD model for the shredder. I offset the face by my desired height and then drew a circle of my desired diameter. And then I used the loft function to connect A to B. After which I used the shell function to, well, make a shell. I went through a couple of iterations, some of them not fitting at all, some fitting too loosely, before I realized that I was never going to get it exactly right with the sieve. Partly because the sieve is no longer square due to all the abuse, but also because there are welds in the corner. So instead, I hopped back into Onshape and I modeled an adapter sleeve to go over the smaller version of the funnel. I then used the Boolean function to cut away the exact shape of the funnel, and then I intentionally made the outer walls too big. I then printed it in Polymaker's 90A very squishy TPU, and with only one 0.6 millimeter outer wall and relatively little sparse infill so that it would have that extra squish. And it actually worked. The sleeve is now held in place quite nicely while still being removable, and even when the shredder is rocking, it doesn't come a-knockin'. And as you can see, all of these little wood shreds and all this welding flux is now falling outside of the bin, which hopefully will be enough to keep my filament shreds clean enough so that I can extrude them into filament. But unfortunately, that is far from the biggest problem I actually have with the shredder. The biggest problem I have with the shredder is actually a twofold one, and I do think that the two problems are related. First, the friction on both the plastic on the steel and the steel on itself because of my imperfectly made shredder are causing an insane amount of heat, like melting the PLA into goop levels of heat, which is causing it to not actually push the threads through, but rather churn everything into dough. And second, even when the shredder is relatively cold, the material just isn't going through the sieve fast enough. This shredder is designed to be used with 8mm holes, but those are way too big for my extruder setup. So you might recall that I swapped out the sieve with a 4.5mm one. Well, material keeps building up rather than actually going through the holes, which means that the heat also builds up in the material, which compounds my issues. To solve this, I wanted to try using one solution for both problems. I figured if I could move the heat through while also creating significant enough negative pressure inside the hopper, maybe, just maybe, I could expel the material fast enough to actually prevent significant buildup of heat and material, or at least extend my duty cycle from a few minutes to half-an-hour sessions. Now, I originally was going to use a 4-inch duct fan, but that just was not powerful enough. So instead, I grabbed one of these awesome 12-volt turbine-style fans that I discovered at Smurf last year. These little guys are awesome. They move an insane amount of air, and they're also incredibly small and compact. So while I was at it, you can see I rebuilt the entire hopper to be a straight shot down, and I made it significantly smaller inside so that it's easier to create negative pressure in there, and the filament has less room to fly around. So now it was time to build some kind of adapter to actually mount this thing. Unfortunately, it's designed in a way that the airflow actually goes in the direction of the control board, and flipping the polarities of the wires doesn't change the direction of the airflow, it just fries the board. Ask me how I know. So the challenge here was to design something to mount the turbine onto the top of the hopper, which is removable, but which also safely routes the cables away from the control board while simultaneously protecting the board from flying plastic particles. This, once again, was pretty easy design-wise. Because I would need a lip on the bottom to secure it to the plexiglass, I did this using the revolve feature, But in retrospect, it actually probably would have been easier to extrude the main body shape vertically and then deal with the revolving of the bottom lip, because it was a little bit of a pain to then go back and cut out the cable channel and add a kind of outer sheath once everything was done. But no matter. While I was at it, I also modeled a nice little nub here that I can use to attach the controlling potentiometer so that it's secured in place. Now this, as you can see, worked perfectly, and it even has a lip inside to prevent the motor from actually sliding into the shredder. But you might be wondering, what about protecting the PCB on the inside from flying plastic? Well, for this, I once again actually just made use of the slicer rather than CAD. Sometimes, particularly when it comes to modeling things like a mesh, it's just way easier to let the slicer deal with it. So I just added a circle in the diameter that I needed and the height that I wanted, and I played with the infill until the holes were small enough to protect the PCB. So much easier than modeling the mesh in the slicer. As for whether or not this actually solved my problem, the jury is still out. It definitely pushes a ton of heat through the shredder, and when I run it, particularly if the shredder is going in reverse, I do notice an increased amount of material actually exiting the sieve. The problem here is that the barrel jacks that I had on hand are not nearly a high enough gauge for something that draws as much amperage as this fan. So they are heating up like crazy, and I can't actually leave the fan running constantly. So I am still struggling with both heat and material buildup. I've actually got some better barrel jack on order, but in the meantime, if any of you out there have any ideas as to how I can improve the shredder throughput and reduce the heat inside, I'm definitely all ears. So those are a few of the little design challenges and projects that I've been up to recently around the studio. I really hope that they were informative and that you actually learned something that you can now use to apply to your own projects in the near future. And hey, let me know either by hitting that like button below or down in the comments below, which I do read every single one of them, if you guys like this type of video. I've actually got a bunch of other projects that didn't quite fit into this one, but if this video does well, I will be happy to do more videos like this in the future. Anyways, that's all for this week, but I'll see all of you on the next layer.